it's better. I'm getting some delay here. Just a minute. Okay. Hello, everyone. Good morning, good afternoon, good evening. I'd like you to check if my doing well. And a video too, I guess I know the. Okay, now it should be better, right? So, let me start over. Hello, everyone. Good morning, good afternoon, good evening. It's so nice to have you here on this Friday. And actually, today for Red Hat is a Red Hat Recharge Day. So most of the company, I guess, is taking a day off, but not me, because I'm going to be recharged by presenting you the 5 features you must know about Java 14. So you know, a couple of weeks ago, Java turned 25. So some of us are used to older versions of Java, so we don't know what happened in version like 9, 10, 11, 12, 13. And I'm going to show what is new on Java 14. Okay, and let me check the chat here. I want to say hi to a lot of people. Hello to the Netherlands, to Austria, what else to Barcelona. And I'm seeing some complaints in the chat. Yes, it was choppy in the beginning because guess what? I forgot to turn off Wi-Fi. Now I'm on the wires, so it should be good. Okay. Edward saying looks fine now. Indeed, was choppy before. Yes. I hope I solved the issue. Sometimes I forget to turn off the Wi-Fi, but now everything is like wired Ethernet. So the connection to streaming, I guess it should be good. But if you have any issues, please post with me on the chat. Hello from Romania, George. Yes, so nice to have you here on this Friday. So I'm super excited. We're going to share some love about Java 14, okay? So 5 features you must know. So let me introduce myself properly too. My name is Edson Yanaga. I'm a director of developer experience at Red Hat. My Twitter is @Yanaga. So just in case you don't follow me yet, you can go here. Oops, the other side. You can go here and follow me on Twitter. I'm also a Java champion and a Microsoft MVP. And I was born in Brazil, but all of my grandparents are Japanese. But right now I'm streaming from Raleigh, North Carolina. So as I mentioned before, Java is 25, and some of us, maybe most of us, missed the new features because now Java is changing so fast. So we were using like Java 8 yesterday, and now we're already on Java 14. So what changed in the last versions? I won't be covering what changed in the previous versions, but I'll be showing what is brand new in Java 14, which is the latest release of Java as of today. Okay. So what are some of the features that you should know about Java 14? But instead of talking about that, because some people present that with slides and I think it's super boring, I prefer to show you codes. So let's switch to code. So the first one that we're going to show is text blocks. So let me switch here to my VS Code. I hope you can all see here. Can see my screen. So what is new? In the past, if you wanted to have to type complex HTML statements or YAML these days even, or if you wanted to type, for example, SQL statements, it was very hard for us because we would type something like this. Oh gosh. String SQL, and we would type select star from developer D, and we would have to type plus and where d.name equals to something and then another plus, and it would keep going on and on. It would be very hard to read later. So because we had a lot of quotes, lots of plus, lots of enters, lots of new lines, so it would be hard to be typing the strings. But that's why sometimes we created DSLs for us to be populating the string so we could have a more readable format for some things like SQL statements. But with Java 14, and just be aware that this is still a preview feature, so it could change, it can improve in the later versions, but I think it's here to stay. Okay, you might have some changes, but the feature overall is here to stay. So instead of typing these kind of things, what could I do, for example, in Java 14? So I'm going to type here. So if I want a test block in Java 14, all I have to do is to type like free quotes and another free quotes here. And that's it. I have a text block. So everything that I type here is going to be, I could even type an HTML here, HTML, then I can put some indentation, can put some title, hello, actually Java 14, title, head, I should be typing that properly, and then I could type a body, and h1, hi. Okay, that's your typical HTML. So what I did, using the test block to be typing this HTML, so it will preserve the formatting that I did. So here I used some, actually used tabs, but it's formatting in spaces, so we will keep those spaces where in the string. So if I just decide to type, to print out this string, which is not SQL anymore, actually it's HTML, but assume it's working. If I just run this file, you'll be able to see here in the output that it preserved the HTML. Okay, so I have the HTML, you have the tabs, you have the formatting, you have the indentation, you have everything that you wanted to. And actually, I think this is still a preview feature, so sometimes it doesn't work. So how we should work is that whenever you have those spaces, it's going to compute the meaningful space. So usually I'm just using this for indentation. But from my experiments using Java, oops, no, text blocks here. If I use this type of indentation, like if I just align here on the previous statement, it's going to ignore the white spaces that I have here before. For example, I have 4 spaces here. So if I run it again, you see that I don't have the non-meaningful white spaces on the left. Okay, I checked the documentation. It should work if I had like an indentation more on the right, but you know, it's a preview feature. Some things are changing. I would have to say, for example, when you have a stack trace here in the bottom and you're using text blocks, and you're checking, oh, I have an exception on line 15. It's not going to show you 15, it's going to show you like 12. And why is that? Because the stack trace is computing all of this text block, at least right now, as one single line, instead of computing that like 6 or 7 lines in the stack trace. Okay, so that's something that I'm pretty sure is going to be fixed in the newer versions of Java, because this is a preview feature they're still working on. But this is just like, as I said before, this is a preview feature just for you to show what is possible with Java. You can use with Java 14. It is working, but you might have some gotchas. For example, I learned that especially if you're reading the stack trace numbers don't follow exactly the lines of my code, because it's considering all of this block to be a single line of code. Okay, that's the only gotcha. And it ignores the non-meaningful white space on the left. So it's just the algorithm is that's just gonna keep following the lines until it computes them, and you see, well, I don't have anything but white space on the left in all of the lines on this text block. So this white space must be non-meaningful. So that's how it works. But after the first meaningful character, everything else is computed and the formatting is preserved. So that's how text blocks works. And actually, I think this is the simplest new feature of Java 14. Okay. What else can we have here? We had test blocks, and now we can go to switch expressions. So switch expressions. And switch back to my code here. I created some classes before so we could use that. So let's try to do a traditional switch statement and check what changed before later. So static void demo, I'm going to receive, for example, an int I. And traditional switch statements are used, for example, if I want to do something based on a value. For example, if I have an integer or if I have an enum, they're very used for that. But it's a very common pattern. For example, if I want to compute something or have a result, I want to switch depending on the input that I had. So I would declare, for example, int results, and I would switch the expression I. So case it was 1, or case it was 2. I would get like result receives 45, and case 3 result will receive 32, or else default would result would receive 100. So this is a typical and application of switch statements. So what are the issues of this thing? So if I run here, you see that I probably have a bug. So I have to run this file. So if I run here, you'll be able to see, oh, I didn't call this method, so that's why it's not showing anything, demo, and I'm going to pass 2, okay? So as a programmer, you would expect that it would print 45, but I guess we'll have a bug here. Yes, because it's printing 100. So it's very common for us, the Java developers, when using switch statements. We forgot that, well, the traditional switch statement is just a fall through algorithm. So if I don't type a break here, it's going to just fall through to the next line, and it's going to, well, you don't need a break here, but just in case, it would be a nice thing, just in case you reorder or refactor the stuff. So if I run it again, then I'll be able to have the proper result 45, okay? So we were thinking, well, if it is a common use case, this is a switch statement, which means that it doesn't return any value, so I have to type it this way. So we're thinking, what if we could refactor this switch statement to be an expression instead of just a statement? So the switch could return a result. And moreover, instead of just applying to ints or enums, for example, we could use that to change to apply to strings too. So let's try to change. So this is the old version. I'm going to show how the switch statement can work with Java 14. And again, this is still a preview feature, but I think they accomplished a very good result so far. So let's switch here, string, and I'm going to apply other logic here. So I'm still going to print an int, but instead of doing like the switch statement in a separate line, I can use it in the same line, because now, as I said before, it's not a statement anymore. Now it's an expression. So let's call it switch expression because it can return a value. So switch, and I can switch on top of the s, string s that I just received. And remember that because it's an expression, not a statement, I have to end it with a semicolon. So what I can do now, I can say case if the string is ABC, because now we're switching on strings, I want to return 1. And I could do, so actually if the string is BCD, I could be returning 1, 2, and default, I could be returning something like 45, okay? Or it could be case CDE, I could be returning like 2. And if you want to be picky about indentation, I could even type this. So all of the results, like all of the errors, are in the same line. So how does it work? If I do this and I type demo and I pass the string ABC, it should be printing the number 1. So let's see if it works properly. Yes, number 1, because again, just in case this executes, case 1, ABC, it matched it, it's going to return this. I think this is kind of a lambda. And actually, since we're talking that this is a lambda, since if you want to declare a variable here, before that, if you wanted to declare a variable inside the switch, it would be a global variable inside the switch statement. So I couldn't declare, like, for example, 2 variables called I inside the same switch statement. But since we're using switch expressions here, if I want to perform more than one line of code here, I would have to create to open the brackets, and I would have to type here int I, which means that I could declare more than int I here. I could declare int I here in the bottom too. So I have another scope whenever I open the brackets. So that's another benefit of using the switch expression. Okay. And if you know that, for example, ABC and BCD, they're both returning the same result in my switch expression, I don't even have to type repeated cases, which was the case of the previous switch statement. I could type, for example, BCD on the same line, and it should just work. Okay. So, for example, instead of ABC, if I switch that to BCD, the result should still be 1. Okay. You can see here in my output, the result is still 1, which is very nice. I think it's another nice improvement of switch expressions and switch statements. So now we can do that with integers, with ints, integer values. We can do with enums, and we can do that with strings too. Okay. So this is about the switch expressions. Next feature that we have to show is pattern matching for instance of. So let's try to do another. Okay, let's see if I created a file or else pattern records and for instance of. Okay, I created one. So suppose that I have this class instance of, and I know how many times have we ever created, for example, code like this. So if I'm running equals methods, I would say, well, if object instance of, then instance of other receives objects, and I would need to tap to perform a cast here. Okay. Oops, sorry. Thank you, Wesley. You can't see the code. Oh, come on. Code. I'm pressing the wrong buttons here. So, thank you very much for pointing me out. So let's go back. So, if I have instance of here, I'm creating equals method. And I know how many times we had to type, for example, if object instance of, and if it enters the if, we are pretty sure that object is of type instance of. But still, we would have to make this explicit cast here. Just saying, well, I know, and you have to type another name instance of other, and then just perform the operations, then return true, for example, or else return false. Okay. Yeah, Yuki is pointing out to me where's the code, and DJ Maddie, thank you very much for pointing out. I can read the message, so if anything happens, just point me here in the chat. I'll be monitoring, but thank you very much for pointing me out this. Instance of, so we had to perform this explicit cast. So what we can do now is that instead of just using this with pattern matching inside instance of statements, we can ignore this, and we can just type here instance of other. And I could, for example, return other words, okay? Other dot clone or something, which is we shouldn't be using anyway. But just to say that you don't have to make an explicit cast anymore when using instance of statements. You can just use the instance of operator, the name of the class, and you can immediately following the type, you can declare a name, an identifier. So will be used to this identifier saying that this particular one is of type instance of, okay? And another benefit of using that, okay, let's try to create a method here. So public static void demo, and if I pass an object, I can do things like this. For example, if object instance of string, I can say string s, and as soon as I declare this identifier string s, I can immediately later use this for and s_length greater than 4. I can do a sysout, it's a string, it's greater than 4. Okay, so immediately in the same expression, you can use the instance of operator with a pattern matching. So you can declare a new identifier, and you can even you just get end and s.length greater than 4, which is very nice, by the way. So I could use, for example, demo, and I pass a string, and I say 1, 2, 3, 4, 5. And if I just execute this class, okay, it's going to print, yes, it's a string, and it's greater than 4. Pretty cool, isn't it? I think it is. Okay, so that's what I had to say about instance of pattern matching. So let me get back here to the slides, and I hope that I'll be able to switch the screen. Records. So this is probably one of my favorite new features of Java 14. It's going to be very useful. So let's switch back to the code. Yeah, as you can see it. So I'm going to open another file here. Records. So how many times when we were trying to declare some classes, we were just like DTOs, placeholders for information. So we want to create some tuples, or for example, I could say private final string s and private final int I, and I would need to create a constructor. I would need to declare maybe a factory method. I would need to provide the getters and anything else. And remember, most of the time DTOs should be immutable. So sometimes I would declare, for example, a final, or I would declare, for example, a private constructor. So instead of doing this, and we might be arguing that every time we declare such methods, or such value objects, or DTOs, I'm saying value object because I'm very using domain-driven design terminology, so it's very common for us to be creating these immutable classes, which don't have, most of the times they don't have behavior, but they have a lot of values and they're storing that kind of things. But you have to type the fields, you have to type, of course, always equals, hash code, toString, and provide the getters for this information, which is just boilerplate code. So what if you could make our lives easier? Instead of declaring this type of classes, we could create another type of entity, which in Java 14, it's still a preview feature, which we call records. And actually, in later versions of Java, depending on the development of the different projects inside the JDK, records could be different types of objects inside the Java heap. For example, it wouldn't need to have an identity. They would become true value objects, which would reduce the amount of memory that they're consuming greatly. So this is another food for thought. I know the JDK engineers are thinking about that, but right now, think about records as a glorified class, which is a very useful glorified class, but it's going to be improved later on. So what can we do here? For example, as I mentioned before, if you think of records as a class, they can be static classes, they can be inner classes. So I'm going to declare a record here as a static class, as a static record actually. I'm going to do public stack records, and I could say that this record is going to be a person, and this person is going to have some fields. For example, it should have a string name, and also could have, for example, a string address. Okay, and that's it. The compiler is going to generate the fields, the final fields for me. Remember, this is a final class. It can't be abstract, and since it's final, you can't have children of this particular record. And it's going to declare the final fields name, address, is going to implement for me the equals, the hash code, and toString, and is going to create the getters too. I'm saying getters, but we should be naming them accessors, because we don't use the traditional Java Bean syntax of get x, get y. We're going to use this particular record. It's going to generate methods, for example, with the name of the property. So it's going to be called name, and it's going to be called address. And how do I use this particular address? So, and here I have a question from Anderson. Is record a good alternative to libraries like Lombok? Probably. I know some people use Lombok. I don't use it because I don't like, but it's just particular taste. I know it works very well for other people. I'm just an old school person. I prefer to see the code, but I know that implementing by yourself equals hash code and all of this stuff is very error prone. You should be always implementing tests. So it's very nice when you know that the JDK is going to write something like that is for you. So yes, I would say that if you're using records, using most of the Lombok annotations would be unnecessary. So records would allow you to reduce a lot of the boilerplate code, even though it wasn't the goal. The goal is to try to make things more readable. So when you see a record here in the code, you can clearly see the intent of this particular class. It's going to be a placeholder for information. It's going to be a final class. You should be used as a value object. You know that equals hash code and toString are implemented. So maybe it's more about readability and intent declaration rather than just trying to save lines of code and rather than trying to replace Lombok. Okay. And another question here is from Prabhat: is record always going to be final? Yes, records are going to be final, but if you need to perform polymorphism inside of a record, records are classes. Think of that as classes. So they can implement interfaces. And with Java 15, we have a new feature, which is, of course, it will be preview, called sealed classes, which will will be a perfect combination with records and sealed classes. But maybe when Java 15 is released, I'll be able to show and talk more about that. I was even thinking about how can I match the effective Java factory methods and builder with records. I have some ideas, but I'm almost running out of time, so I won't be able to show them to you. Okay, So if you create a person, a record here, how do I instantiate a new person? I can just create person, and you can see that I already have an implicit constructor with all of the fields. So I can say Yanaga, and the address is going to be North Carolina. Okay, and if I decide to print this one, person, out person. If I print here, you can see that, let's run this class. You can see they already have here in the output person name equals Yanaga, and address is equals to North Carolina. So yes, very nice feature that we can use with records. And what else? If I have two, let's close here. Let's suppose that I have here, I have person 1 and person 2, and sometimes people forget to implement equals in hash code or implement it wrong, so you don't have like proper semantics on your object. So if a person equals person 2, you know that if it's a record, the equals and hash code and toString are properly implemented. So if they just decide to run it again, you can see that it is true because the two objects are equal and they should be treated as DTOs. Okay. So I have another question here. Wesley is asking, would record classes be a good option for JPA entities? I wouldn't say JPA entities because JPA entities, they have a requirement, since it's, think of that as a domain-driven design entity, the values, they change over time. So even though we should be striving to reduce mutability inside our JPA entities, they are designed to be mutable. Okay, because they change over time, because we're mapping that to database rows, and database rows, they evolve over time. But I can see that, for example, the properties, I could create an phone number record, and that could be the property of the JPA entity. I think that could be a very nice match. And but even though we can have some discussion about if the properties could be, for example, records, I think that right now I can think a perfect use case for records in JPA. For example, when you create custom queries and you want to retrieve a DTO from your JPQL query, yes, records are a perfect match for that. Okay, so you can create then just records with a single liner with all of the fields that need to be retrieved from the query, and JPQL or JPA Hibernate will populate those DTOs, those records, and return that for you. Okay. And here George says records does not fit with Spring proxying. Doesn't fit because they are final, but, and again, but if you use them, if you use the records and decide them to implement some interface, yes, then you'll be able to do some proxying. So I had some thoughts about using interfaces, sealed classes, and records, but as I've said before, it's only 30 minutes this session. I won't be able to present, but maybe I'll write a blog post or publish a video about it later. Okay, so yeah, this is the records that I have other things to show, but I think it's good enough for today. And the last feature that I have to show you today, which is not exactly a feature for you as a developer running code, but we have helpful null pointer exceptions. So let's try to craft some codes here. So if I have a null pointer, and I'm going to improve on the previous example. So let's create a class here, record. Public static record person. I'm going to give a string name. I'm going to create another record called address. Cool, isn't it? I think super cool that we can create like classes or records like this and one-liners. Record, and I can create address. For example, it's again string street. And I can have a phone number, phone, and then again, and I'm going to create another record. Okay, which is going to be int area code, int number. Okay, I created 3 records. And by the way, one of the things that I realized when experimenting, if you declare a public class, which is our public record, your constructor is public too. If you create a package private record, your constructor is also package private. So because I wanted to create a factor method inside a record, and it doesn't allow me to do so because if it's a public class, I can't declare a private constructor. So the constructor is always implicit. And by the way, if you want to check how can I perform some validation when creating a record, I can create, for example, the syntax is this one, person. So it's going to perform some validation. If name dot equals to new, throws legal argument exception. Okay, we could be doing things throw and needs to be public. Okay, so as I mentioned before, if it's a public record, then the constructor must be public and always generates an implicit constructor. But if you want to perform anything inside the constructor, that's the syntax for doing that in the record. Okay, so let's remove it for now because it's just noise, because we're talking about null pointer exceptions right now. And if I just declare some people here, so person, so let's create a list of, and I'm going to create a new person here. So new person, name is going to be John with a new address. And the address, oops, I imported the wrong class. Address, and it's going to have a street name, street, and a new phone number. So if I type a new phone number, 123 1234. Okay, if I type it everything correctly here. Okay, I hope I did it right. List, I didn't import the right list. Okay, so I created a list with one element. And let's try to add more people to my list. So 1, 2, 3, 4, 5. So we have a lot of Johns here on my list. So let's try to get some proper indentation here. So I forgot the commas. It's okay. I have a proper list. So what common mistake that we did in the past was very hard, because in this case, if I wanted to chain the invocation, I would say person, like list of person people. Okay, so I have this. So if I get like people get 0, no, it's person, I would say people.address.phone.area code. And if I try to execute anything about that, and if I got a null pointer exception, what is null? Is the get 0 returning null? Is the address returning null? Is the phone returning null? So that's why I get a null pointer exception. So we would be debugging this code, or we would be putting multiple print line statements, like with people get is it we would be doing, and I did that many times in the past. People.get 0 to see if it's printing null. Then I would do the same here, and I would say people.get 0.address, and I would see if it's null. So we would be debugging, trying to find which of the fields is null. So what we can do, and it would get even worse when using lambdas. I know that some friends, for example, and I've even thought about that, because when we're using lambdas, if we're using this kind of people.stream, and suppose that we want to filter, and the predicate is like p person, p.address.phone.area code greater than 200. And I get a for each system.out println. Okay, and if I do this, and if I have an exception here, it would be very hard for me to realize where is the issue, where is the null. So it would be even hard for me to debug, because I would have to debug instead of just doing some printlns. So some friends, for example, even told me that they abolished this kind of statements inside lambdas, because it would be really hard for them to figure out what happens if you have a stack trace. But luckily, let's try to emulate a null pointer here. So this particular address is going to be null. So if I decide to do this, I'll have a null pointer exception. You see, null pointer exception, I have a null pointer inside the lambda, which means that on line 17, I have an error, but I still have no idea what happened here. And I was figuring out, oh, it was featured as a new feature of Java 14, but where is the meaningful null pointer here when I have? Well, the gotcha is that in Java 14 at least, you can have a helpful null pointer exception, but it is disabled by default. So how do I enable this thing and running? So what I had to do here, I had to go here. And whenever you're doing here, records, instance soft, switches, current file, null pointer. So I decide to write here, I have to add a VMR. So you have to add this VMR to your code when you're running your Java class, and I just copy paste because it's very easy for you to miss something. But you have to run your Java code using this VMR dash XX column plus show code details in exception messages. So it's a pretty long flag. Maybe it's going to be like enabled by default in future versions of the Java of the JVM, but right now you need to enable this flag explicitly, so that's what I'm doing. So I just saved the file and I go back here to null pointer. If I run this class again, you will see that now I have an exception with a meaningful error. I'm going to take my face out of the front so you'll be able to see that. So exception in thread main, null pointer exception cannot invoke null pointer address.phone because the return value of Conrad hat person.address is null, which is saying that the address is null, and that's why I'm having a null pointer exception, which is much better than what we had before because just null pointer exception on that particular line. So I know that a lot of Java developers, they even decided that, well, I'm not going to change statements in my code anymore because whenever I have a null pointer, I have no idea which piece provoked the null pointer exception. Now, you can change your method invocations again, because if you enable the helpful null pointer exceptions, you'll be able to clearly see which part of your expression is causing the null pointer exception. Okay? And I think I have here with Anderson. For me, this improvement in null pointer exception is the best feature of this version. It helps a lot checking bugs in production. Well, I have to think that it's a super nice feature, even though it doesn't add new capabilities for you as a Java developer. I'm pretty sure it's super helpful if you're having bugs, especially when it doesn't happen in your machine, but it happens in production. So DJ Maddings agreed, and I agree. It's super useful, even though it's not a developer feature, but it's going to save a lot of hours whenever we have some null pointer exception in productions. My particular opinion is that null pointer exceptions should never happen in production because you should be never using null. But since they do happen, it's much better if you know exactly in which piece of your code that particular thing is happening. Okay, and we have like lots of people agreeing, awesome feature. I agree with you all. Yes, we were all experienced Java developers. We've been bitten by the null pointer exception, and it's going to be super helpful. And Java 14 has like more features regarding garbage collector and other non-developer stuff. But these are, for me at least, these are the five most important features that we should be learning when regarding Java 14. And I hope you enjoyed this session. I ran a bit over time, 10 minutes over time. I really enjoyed your patience. I really appreciate your patience for staying with me until 9:40 here in the East Coast of the US. Thank you very much. Follow me on Twitter if you want to know more information about all of this new feature of Java and other stuff. And I hope to see you again on the next DevNation Tech Talk, because we always have like awesome content on this DevNation Tech Talks on Friday. Take care, stay safe, goodbye.